This is a hypothesis test between two population means for independent samples when both population standard deviations are known. Given the information below, can you reject the claim that male and female high school students have equal ACT scores? Use a level of significance of 0.05. Okay, so the information is summarized. Clearly, I have independent samples here. For the male group, the sample size was 43 with a corresponding sample mean of 21.1 and an assumed population standard deviation of 5.0. For the female group, the sample size was 56, the sample mean was 20.9, and the assumed population standard deviation is 4.7. Because the population standard deviations are known and our sample sizes are more than 30, this is going to be a form of a z-test. Our standardized test statistic will follow a z-score, and we can get the critical value from the standard normal table or the normal CDF function in the calculator. We need to set up the null and the alternative in terms of the population parameters mu sub 1 and mu sub 2. The claim is that male and female high school students have equal ACT scores. So I've already labeled the male group as population 1. So in parameter notation, if the claim is that the average ACT scores are equal, that would be mu1, the average male group mean, is equal to mu2. So this is the claim. Because this contains the case of equality, this is the null. That makes the alternative mu1 not equal to mu2. So this will be a two-tailed test. Our standardized test statistic is x bar sub 1 minus x bar sub 2 minus mu sub 1 minus mu sub 2. This numerator follows the same structure as a single sample hypothesis test for population mean, what we observe, but now our point estimate will be the observed difference between the two sample means minus the hypothesized difference. And an alternative way to write our null and our alternative is to move mu sub 2 over to the left side using subtraction, and this is a perfectly acceptable way to write your null and your alternative. So moving mu sub 2 over to the left side, the right side becomes 0. So this is the claimed difference. We could test a claim for a difference other than 0, but if you're taking my stats class, we're not going to be doing that. We're just going to assume that we're testing a difference versus no difference, or a difference greater than 0, or a difference less than 0. So what makes it nice for this formula is this piece here becomes 0, and then the denominator is the standard error for the sampling distribution of the difference of sampling means. So that's going to be sigma, whoops, made a mistake there, sigma sub 1 squared over n sub 1 plus sigma sub 2 squared over n sub 2. Now sigma sub 1 squared, that's going to be the sample variance for, the population variance for the first group, and here's the population variance for the second group. Okay, because remember, the relationship between sigma and sigma squared is that this is the standard deviation, this is the variance. The variance is the standard deviation squared. So inputting the information into the problem, I have 21.1 minus 20.9. It's going to be a positive test statistic. And again, I'm subtracting 0 because I'm assuming no difference between the two in my null statement, over 5.0 squared over 43 plus 4.7 squared over 56. Now a little bit of caution here. If the problem had already given sigmas as sigma squared, in other words, if the problem already gave variance rather than standard deviation, do not square again in this denominator. Okay, so this test statistic is a little clunky because of that denominator expression. Later I will show you how to get the standardized test statistic and p-value directly from the calculator. So using parentheses around my numerator expression and inputting that denominator expression, I probably didn't need the 0.0 there. Okay. Just double checking everything. It's very easy to make an inputting error here. Okay, so I get a standardized test statistic of 0.202, rounding to 3 decimal places. And because this is a two-tailed test, I want to find the 2 critical values that are symmetric using our level of significance of 0.05. At this point in the semester, you should be very comfortable with finding a critical value or critical values using a test that involves the z-distribution. When alpha equals 0.05, that's a common one. Okay, so the critical values for this are going to be plus or minus 1.96. You can verify that yourself using the inverse normal function in your calculator. Okay, in other words, I've got 0.025 amount of area in each of these tails. Sorry, being a little sloppy here. So positive 1.96, negative 1.96. Our standardized test statistic is nowhere near the area of rejection. So the decision will be to fail to reject the null hypothesis. So to answer the question, can you reject the claim that male and female high school students have equal ACT scores? There is insufficient evidence, or there is not enough evidence to reject that claim. Now to find the p-value, remember it's going to be the area with respect to extremity for the standardized test statistic. But when I have a two-tailed test, this is going to be half of the p-value. So you could use your normal CDF function in your calculator using the test statistic as the lower bound and find the area to the right and then double it. So you can get it back in terms for comparison to the level of significance, because the level of significance was divided in half here. So I'm going to go ahead and use the calculator to get that p-value directly. Going to stat, arrow over to tests. Option 3 is the 2-sample z-test. And you'll either have the data in 2 separate lists, or you'll have the summary statistics, which is what I have for this problem. So you'll see it's going to need the standard deviations, the sample means, and the sample sizes. You want to make sure you put everything in order. In other words, you don't want to put in the standard deviation for male, but then the sample mean for female here. Okay, so make sure to double check what you input. The standard deviation for male was 5.0. The standard deviation for female was 4.7. The sample mean for male was 21.1. The sample size for male was 43. The sample mean for female was 20.9. Sample size 56. And here I need to change my direction of alternative. This is a two-tailed test, so I want to select not equal and then calculate. You'll see that the standardized test statistic is the same as what I got when I did this by hand. And here's the corresponding p-value. Okay, rounding to 3 decimal places, that's 0.840. Comparing it to our level of significance, the p-value is greater than or equal to our level of significance, reaffirming the decision that we want to fail to reject the null.